topic of today's discussion is recycled glass media and choosing the right media for your pool. So just to introduce Jim, this is Jimmy Lamb of Dryden Aqua, who manufacture AFM recycled glass filter media. So to kick things off, really Jimmy, if you could give us an introduction to what recycled glass media is, what are the basic properties and processes that make recycled glass suitable for filter media?
Okay, yeah, so at Dryden Aqua, at our facility up there in Edinburgh, we are literally taking bottles from the bottle banks. So in Edinburgh, for example, we receive over 50% of clear glass, which isn't a product that we particularly want, but we will repurpose that clear glass. It's the green and the brown glass that we're looking for a target colour to produce our AFM.
Just the simple colour of the glass makes a big difference then.
Indeed, yeah. So you'll notice that AFM is around about 98% just green and brown glass. And the reason why we want to target that colour is because the metal oxides that give the glass that colour. So in the case of green glass, it's a chromium oxide. And in the brown glass, it's ferric oxide. This already has a natural bioresistance. So we're really just enhancing that bioresistance property to produce AFM.
So in terms of that, Jim, obviously we've all been in this industry quite a long time. You can obviously tell by our hairstyles. But you know, a lot of these pool operators are used to the old silica sand. Now that's been about for hundreds of years. So, you know, what is wrong with the sand?
Absolutely nothing wrong with sand. Yeah, it's, as you said, it's made a perfect filter media for many, many years. But it does break down and it does become subject to biofouling over time. And this is one of the reasons why it needs to be replaced, typically, 5 to 10 years, maybe a bit longer if the hydraulics of a system is very good. But because of the biofouling that occurs over time in sand media, you do get the production of some undesirable chlorine byproducts, should we say, such as THMs and trichloramine in the pool. Yeah, so by employing our technology, you eliminate that substrate for bacteria to grow, and you keep the bacteria free floating for the chlorine then to actually deal with it in a more efficient way.
I think it's worth saying, isn't it, that AFM media, when it's backwashing, it's easier to clean than sand, and I think that's a big point. Is that sand, yes, is very good at holding on to dirt, but it's too good, and you try to backwash it, and it's much more difficult to release the dirt from the media bed.
Once you've got that biocoagulation that's occurred within a sand media, it can be quite difficult to break it up, particularly with the slow velocities that we tend to use here in the UK. You know, we've always recommended a minimum of 30 meters an hour for sand. Well, if you compare that to our friends on the continent, you know, German DIN standards, they're more up to 50 to 60 meters an hour for good reason. Aeration is often recommended as well if it's a filter that's been designed for aeration. And again, that's really to try and break up the biocoagulation of sand media.
Yeah,
so
it gets quite compact, doesn't it?
Yeah, no, exactly. So with AFM, because we have that bioresistance, you know, it's not just the fact that it's the green and the brown glass that gives it that bioresistance. We actually put it through an activation process, which is a 2-step chemical and a thermal curing process. So this is where we really manipulate the surface of the glass to give it a certain charge. And that's what makes it very difficult for bacteria to actually adhere to the surface of glass. Tests have shown in terms of filtration performance that sand, again, depending on where it's come from, will differ. These are independent analysis that have been done. It will typically filter down to about 20 micron. That's at a 20 meter an hour filtration velocity. Now, when you're trying to protect yourself against the likes of Cryptosporidia, which is typically 3 to 6 micron in size, this can quite easily pass through a sand media bed depth. When you compare this to AFM, at the same velocity, we're filtering 95% of particles down to 1 micron. So we create a barrier, and that helps to protect Cryptosporidia from passing through the bed and back into the pool if ever there's an outbreak.
Is that because of the properties of the media, the charge of the glass media, as well as, obviously there are effects like flocculation and settling, all these different mechanisms of filtration. But yeah, is it to do with the charge as well?
Partly to do with the charge, but it's also down to do with the shape and size of each granule as well. We talked about backwashing there of the sand. So at 30 meters an hour for AFM, we are getting a 15 to 20% bed expansion and good fluidization of the bed, because we don't get that biocoagulation. So the debris is released much easier and over a much shorter period of time. So we're typically reducing backwash programs by about 50% in the UK. So that equates to significant water savings as well. So we filter down to a very fine micron. We give a good protection against Cryptosporidia, and then we're using less energy and less water in the backwashing process.
I suppose, Jim, there's a thing there in terms of using less chlorine as well.
Yeah, because it's not combating bacteria in the system, and this is exactly where we get these toxic byproducts forming. If you've got a biofilm that's established within a sand media bed, then the bacteria within that biofilm, they'll consume the urea that's introduced from bathers, whether that's from sweat or from urine. They'll metabolize that and then secrete ammonia, which then reacts with the chlorine to create trichloramine, for example. So if we eliminate that substrate for the bacteria to grow, the urea remains urea. It still reacts with the chlorine, and we get a organochloramine being formed, as opposed to an inorganochloramine. So we create a lot less inorganics compared to a sand system, and it's the inorganics that go on to produce the harmful byproducts. Now, DPD number 3, when you add that to your DPD number 1, doesn't differentiate between the two. So we never guarantee a reduction in your total combined chlorine. It's just the inorganics and the organics that differ. Yeah.
So in practice, it's quite interesting. Yeah. I mean, I've done tests in the past on sites where they've had problems, and you can clearly see a DPD test taken before the filter and one after. And quite often you can lose half a part per million across the filter.
Yeah, quite
half
easy,
a part per million of chlorine. And so that's being used up somewhere. Yeah, exactly.
Yeah. And this brings me back to the subject of backwashing again. So there have been occasions where the backwash has been deficient and we're not getting that fluidization and ejecting the debris from the filter. The trapped particles then can become a harbour for bacteria, and we can get exactly the same formation of toxic byproducts. But backwashing is absolute paramount when it comes to good media filtration.
We have to say it, there are a large number of recycled glass media available on the market. And, there's a lot of discussion about, it's recycled glass media. And I even had a customer that just specified recycled glass media, and the job turned out to be a disaster, and all the media had to be replaced. So what's the difference between your media, normal recycled glass media, and what are the standards? What are the standards we should be looking for?
Yeah, I mean, I think there's been standards have been lacking up until recently, but at the tail end of 2024, there's a new European norm that's been produced that's also being adopted by the British standards, and that's EN 17978 2024. And that's a standard that is a quality standard. It's not a performance standard. It's a quality standard. And it's for glass granulate and beads used in drinking water and swimming pool applications. So there's 3 items really on this standard. First of all, it's the organic content of the media. I think you're allowed up to something like 300 grams per ton. Well, we're about 10 grams per ton with AFM, so it's a very, very clean product. The other governing factor is the metallic content, because you do get a lot of byproducts in a lot of these glass media material. And the third one, which I think is probably the most important, is the tolerance on the grain size that you're specifying. So you've got a tolerance of plus or minus 5%. On our grade 1, for example, which is 0.4 to 0.8 millimeter in size. And then I think you get a 10% tolerance on the support layers. And you need quite sophisticated equipment to actually measure that. And a lot of this equipment comes at great expense. But, there's no expense spared at Dryden because we strive to remain the best. And we've invested millions in our plant and research and development up there in Edinburgh to make sure that we stay one ahead of the game.
Yeah, we saw that, didn't we, Martin, on our visit, didn't we?
Yeah, it was brilliant. Yeah, great visit. Yeah.
You see the amount of investment required.
Yeah, well, last year, really, we invested another 2 million in improving our efficiency, removing the clear glass material. As I say, we receive a huge amount of clear glass up in Edinburgh. Slightly different our plant in Switzerland, because the culture of recycling is a little bit different there. They still go and put the green bottles in the green hole and the brown bottles in the brown hole. So we do get a much higher level of our target material from the start. So that's the difference between the two plants. Is at Switzerland we can afford to wash the raw material at the beginning.
Yeah, it's discipline. We're not disciplined.
Absolutely,
we'll just chuck it anywhere, us lot. Just chuck it anywhere.
Exactly. In a box at the front door and leave it out for the guys to come and collect, and you just send to check everything in that box. So that's the two differences really between the two plants. Is in Switzerland we can wash the raw material at the beginning of the process, but in Edinburgh it'd be crazy to wash over 50% of what we're not going to use. So, we made, as I say, another significant investment to remove that material. That clear glass, that will then go back to producing whiskey bottles or medicine bottles, that kind of thing. We try and have a zero waste policy up there. But just coming back to the performance of glass media, in our experience and the analysis that we've done, is particularly with clear glass, because it breaks in a very different way. So it becomes very slate-like, quite shardy as well. And if you were to run it in your fingers, it would stick to your fingers, which you don't get with AFM because of the shape and the size. But a lot of it is quite flat. So if you consider this to be a piece of glass media, it's like stacking coins on top of each other. So they block up quite quickly. Yep. And then when you put it into that backwash, you've got quite a nice surface area for the water to drive against. But then it flips. And it just drops back down again because you lose that surface area. So you need a huge velocity to try and lift that up and fluidize the bed to eject the material that's trapped in there. And then ultimately what happens, the trapped particles drive deeper and deeper into the bed and eventually clog up the laterals or the nozzle plate at the bottom. And then, as you say, Andy, the whole lot then needs to come out, be replaced.
Fluidizing the bed, that's something that's often overlooked, isn't it, on a lot of jobs that we come across, that there just isn't sufficient backwash speed half the time to be able to get sand clean enough.
Without sight glass on the filter, you don't know what's going on inside during the backwash.
No, you can't. You can't sense any movement at all, can you?
No. You're guessing, really.
Andy, as far as we're concerned on that one, we got this one about the energy is required to produce the glass media, obviously.
Yeah.
Longer term environmental benefits from using it, lifespan, performance, avoiding landfill, all that kind of stuff. I mean, Jimmy, you've touched a bit on that already, but obviously from your perspective, and you'll probably go into this because that's what you educated us on when we came in on our recent visit, is that obviously as far as your filter media is concerned, it can be put back through the system, can't it?
Yeah, we can rework it if needs be, but I think the shipping of that might be a bit inhibitive. Depending if you're coming just down the road in Edinburgh, then no problem. But if it's coming from the southwest, down in deepest darkest depth of Cornwall, then shipping it back to Edinburgh might be a bit pricey.
Yeah.
But look, as long as there's good hydraulic dynamics within the system, we've got it in situ for over 20 years now, and it's still performing as well today as it was 20 odd years ago.
Yeah, it's about 21 years ago since I first used it on a job, and it's still there. It's still there.
Yeah.
It's working great. We've done a couple of chemical cleans on it over the years, maybe because of issues that the customers had, or maybe they've not been backwashing properly. But it's still great, still working great, and so testament to the fact that it does last.
We're talking about the media representing about 90% of the total surface area that the pool water's in contact with at any one time. So there are still other areas where bacteria can grow, whether that's in and around the laterals or the nozzle plates, the filter tank itself, the pipe work, of course, and the pool tank as well. So it's not it's not 100% giving you a bacteria-free system.
Yeah, yeah, of course.
I don't think we'll ever get to that point anyway, and that a lot of that is down to the basics of the people that are getting into our pools as well. We gotta start with the basics of getting them clean before they go in.
Hosing them down, down the breakers before they get in. Yeah.
Just as a side note on that, on the standards for glass, you've got Regulation 31 approval, haven't you, for AFM, or is there a particular type of AFM?
There'll be Reg 31, for use in drinking water in the UK. We've also got NSF as well, which is more applicable to the States. So absolutely, and it is being used in drinking water, and Northern Ireland Water would be our biggest consumer of AFM for their RGF plants over there. So they're on a rollout program there. So working very well.
Yeah, I mean, it's a good testament to the quality of the product, because I know that I've done applications myself for Regulation 31, and it's pretty tough to meet the standards. So obviously it's a quality material if you've managed to get it through that process. So well done.
Yeah. Well, I think you can appreciate, with the amount of investment that we've done up in Edinburgh. You've seen the activation process as well. You don't get to know what the chemicals are used in that process. That's the Colonel, what's his name? The KFC secret, the Coca-Cola secret. But it's not something that we're hiding behind curtains. We do regular trips up there to the factory in Edinburgh and in Switzerland for that matter, and you can see what's going on there. So it's not something that's been made up in a marketing meeting, as some people might suggest.
No. And the other, like you said, that's the secret sauce of your products, but also you could say the secret sauce, well, it's not so secret, but there is a sauce to the filter as well. The quality of the filter makes a big difference as well, doesn't it, Jimmy? I mean, if we take a look at what they do in Austria, Switzerland and Germany in public pools, their filters are much larger, generally taller, of a lot more freeboard space to allow flocculation time. Quite often the bed depths are a bit deeper. So there's a lot that they're doing that typically we don't always embrace here in the UK, is it? We just think a filter is a filter, and but there is a proper design for pool filters.
Absolutely, yeah. I mean, we liken it to the filter being the hardware, and the AFM is the software, and the software is only as good as the hardware. So you're absolutely right. I've come across some installations where the nozzle plate arrangement or the lateral arrangement isn't delivering on the total surface area that's promised on the label on the outside of the filter. And water won't turn around corners. It will take the most direct route that it can. So that will actually increase the filtration velocity, and you've got massive dead spots down the side of the filter. And when you put it into backwash, you're only backwashing up the center of the filter. So you can start to get, biocoagulation in these instances as well. And in the likes of Germany, again, referring to German DIN standards, they tend to work to a 1.2 meter bed depth. So you get more contact time through the media. So deeper bed filtration, and a bigger freeboard, because they're working with much higher velocities in backwash, so they need that freeboard so not to lose media during the backwash. Yeah. Typically here in the UK, what are we, about 1 meter, minimum of 1 meter in terms of bed depth?
About 0.8, aren't we? Yeah, we're 0.8 minimum, aren't we?
Right.
Yeah, if you take into account the support layer, then you compromise on your actual filtration grade bed depth.
And looking at the space in the top of a filter that would comply with the DIN standard, the amount of contact time you've got there, sometimes I've measured it, it's probably at least twice, at least two to three times the contact time that we typically see in budget filters that we put here in the UK. So that space in the top is probably just as important as the rest of the space for the sand as well.
Yeah, and as you say, it's good contact time for coagulation to take place, for flocculation to take place, which will improve your filtration performance typically by a factor of 10. So again, with AFM, if we're filtering 95% particles down to 1 micron, you bring in coagulation, flocculation by a factor of 10, you're down to 0.1 micron. So we're into the realms of ultrafiltration now with AFM. But that's also an interesting subject, because if you're only backwashing at 30 meters an hour and you've got flocculation in there, flocculant in there, you need to break that up. You need to shake that up and eject that out of the filter as well. Yeah, the density of some of these particles as well might need a bit more energy to up and lift out of the vessel as well. It's not just about fluidizing the bed and getting that bed expansion. It's about enough velocity to actually remove the particles. Heavy metals, for example, iron, copper, manganese, heavy metals. There's a clue there. They're going to need a bit more oomph to get them out of the system.
I was going to say, having a good flocculation process and allowing it to complete, that's why we need the time, because if the flocculation is not complete by the time that water gets to the filter bed interface, then, you end up with flocculation happening inside the filter bed, and that's where we get problems.
Yeah, well, the other thing, it goes back to all the equipment as well, flow meters and all that kind of stuff. How many times do we go into plant rooms and there's no flow meters or things like that? They got no idea how quickly their water is circulating. Stop laughing, Jimmy.
So it's all too many times have I been into a plant room where there's no sight glass and there's no flow meter, and you ask them the question, "What's your turnover?" "Oh, about 2 hours." How do you know?
It's like zero dashboard, is there?
Exactly. It's, you're absolutely right. It's like driving without a speedometer. But the flocculant can also pass through the media if it's not given time to form, and especially through shallower bed depths, and enter the pool, flock out on the pool, come back through the system, cause problems with any electrodes on dosing systems.
Yeah, and can you use AFM in high rate filters, Jimmy, or is there limitations to the speed? I know slower is always better, but
of course slower is always better, but the performance is always going to be relative to the filtration velocity. So AFM is used extensively in the domestic pool market, and a lot of these domestic pools are filtering typically up to 50 meters an hour. But no, it's performing very, very well. But you won't get 95% particle removal down to 1 micron at 50 meters an hour. No, that's proven at 20.
Oh.
Yeah.
And
the as I said, the bed depth. Yeah, the bed depth makes a difference as well. You get more particle retention through a deeper bed depth than you will a 300 mil domestic filter at 50 meters an hour.
That's interesting. So looking at where the market is now, and the extent of the adoption of AFM, is it? I know you sell internationally now. At one time, I remember when I first started buying AFM, it was just a factory in Scotland. I can't remember how we found out about it, but I think I bumped into Howard once, I think, and we had a long chat about it. I said, I need to try your media.
Initially, Jimmy, if I'm not mistaken, Howard used to he trialled this AFM filter media in hot tubs and spas, didn't he, to begin with?
Oh, I don't know about that, Martin. I've been working with Dryden.
I'm just going back to Robbie's days, really, to be honest with you. And I'm sure at some point Howard and Robbie had a discussion, and he'd said, and they'd done some experiments in South Wales on some spa filters in South Wales. This will be about 25 years ago.
Okay.
It's anything to do with Robbie. Yeah.
A bit of a history lesson there on a Monday morning.
Yeah. No, well, I've been with Dryden for, it'll be 3 years in May. I can't believe how quickly that's gone. But prior to that, I was working for Polyp Pool Group, who since acquired Golden Coast as a distributor. And it was 2013, I think it was, when Dominic Graff, who basically bought into Howard's business, Dryden Aqua, and approached us at Polyp to become their distributor. So Polyp were very much in the domestic market. Probably about 80% of the business was in the domestic market. So that's how we grew the business in AFM, was through the domestic pool market very successfully. And over the last 12, 18 months, we've opened up the distributorship to some of the larger distributors here in the UK that have got access to the commercial pool market. And we're really seeing some traction now. That's been a really slow burner, as you can imagine, in the commercial pool market. because of the premium price that AFM comes with, for good reason. But that's really getting some traction now. And a lot of it, one example is kind of purely by chance. There was a big commercial pool in the middle of London that had an inferior glass media. And they had one of these sophisticated anti-drowning systems installed called Pool View. Really clever technology where it monitors movement in the water at certain depths over time and raises an alarm. Well, this particular site kept getting false alarms, which is pretty annoying. And it was down to the turbidity of the water. You know, our standards in the UK for turbidity measured in NTU is a maximum of 0.5. I'm not teaching you guys to suck eggs. I know you know all this. The higher the number, the more turbid that the water. So the pool service company then recommended to try AFM, and it solved the problem overnight. But then purely by chance, they started to realise savings in water consumption, chemical consumption. So they're now rolling it out to other sites when they come up for media renewal. So purely by accident.
I think that's a good point. That, you know, yes, you're going to pay more for this product, but the long-term, you know, benefits over many years that you're going to keep that media far outweigh that bit of extra cost up front.
I just thought, Andy, based on what Jimmy just said, it'd be just, how long was that, you know, that inferior glass media? How long had that been in?
I don't know the answer to that question, Martin. Maybe it had been in for some time, and it was only when they had the anti-drowning system installed that they started to, you know, get these problems, and then they put it down to the turbidity of the water. But there's can you name many sites that actually monitor the turbidity?
Oh no, they don't even know what turbidity is. A lot of them. No disrespect meant.
That's it. When you, I find the best way now is just a mobile phone. You know, if you've got a waterproof mobile phone, and you can dip that in the shallow end and look down the pool, that's the best turbidity meter you can get. And it's quite surprising. It's quite surprising what it reveals. I think every pool looks clear when you just look down, when you're walking on the pool side and you look down on the pool. It's only 1.5 meters, 2 meters deep. Every pool looks clean. But you look through the 25 meters or whatever you've got, and a heck of a difference. You can really gauge it then.
But it's only when you put AFM in and then you really start to notice the imperfections on the deep end sump grill and you know, broken tiles that you never seen before. They get comments like that back from installers.
And if you can't get that clarity, you know, if you're not achieving really good clarity in the pool, that's just an indicator that you've got so much debris that's just recirculating around the system, never being removed, and it's just reacting with chlorine. It's there all the time, reacting with chlorine. So, you know, it's a really critical part.
That's when you get that horrible chlorinous smell in the atmosphere as well, in the pool hall. So I think that's the two things that operators really notice when they first swap over to AFM is, first of all, just the sheer clarity of the water. And secondly, they're not getting that horrible chlorine smell, you know, that irritates your eyes, nose and throat. So, you know, that tells us that we're keeping that urea as urea. It's not being metabolized by bacteria into ammonia and creating those byproducts that they gas them.
The only thing I was going to say, and obviously that moves on, Jimmy, to like things like the DAISY system and all that kind of thing, but that might be something that we can talk about again, because obviously you've got various forms of technology which help to create that lovely environment. And obviously the DAISY system is part of that, isn't it? That's getting all the component parts together in order to actually, you know, to purify your pool.
Well, you know, DAISY essentially consists of AFM as the media and APF, which is our all polyfloc as a coagulant flocculant. That gives you DAISY. Yeah. Dryden Aqua integrated is what that stands for. We do have ZPM technology as well, dental mixers, which is a static mixer for mechanical coagulation and mixing of the APF. Yeah, but that's again something maybe we can talk about another time.
And you know, the other thing in terms of that is space as well, because that'll be an interesting conversation, because that sounds really good. But I mean, that's just introduction of sensors all over the place by the sounds of it to me. Sensors on pumps, sensors everywhere.
Low rate, pressure, water level, automatic top up, automatic backwashing, learning how the pool's being used by
fantastic.
AI. Yeah, it's, we're just about to start delivering to our
Yeah.
distributors that system from next week.
I was going to say, recording, being able to record and analyze all that data will just make the job of managing pools so much more efficient. It's going to be driven by data. That's the future, I think.
It's changing the world of managing pools from a reactive system to a proactive system. And part of the neat technology within it that I like is it's intelligent dosing of the chemistry. We can really reduce the amount of chemicals that are being used by the intelligent dosing of this system. Yeah.
So, Jimmy, what I'll do is put some links down in the description for the video. So if anybody's got any questions, wants to contact you, or if they've got any queries on AFM, then we'll put your contact details. What email can people get you on, Jimmy, if they need to contact you?
Yeah, very straightforward. Jimmy, JIMMY, @drydenaqua.com.
Many thanks for your time today. Much appreciated. I hope we've answered a few questions for people, and we'll probably catch up again sometime and have a look at the space system when you've got some data and results. It'll be interesting to see how that system works as well. So,
great stuff. Thanks for the opportunity. I appreciate it. Yeah, good to see you guys.
Thanks a lot, mate.
Cheers.
if you found this content helpful, please help us by clicking the like button below and subscribing to the channel. Thank you.